Okay, so this is going to be our second video for day 8 of Unit 3 for Algebra 2. Um, Also going to be relatively short. We're going to talk about how to perform basic arithmetic with polynomials. Again, we've already been doing this. Um, Not really anything new, but nonetheless, here we go. All it really comes down to is just multiplying and or combining like terms. So I've got two polynomials I want to combine, right? So let's say I want to combine f and g, combine them as in add them together, right? So f plus g, well, that's literally just f plus g, right? And then we see, we don't really need those parentheses because there's nothing being distributed. We don't have to play with any negatives or anything like that. So all it comes down to now is just a matter of combining like terms. So let's start with the highest degree term. Because anytime we mess with polynomials, we want them expressed in standard form. So, for example, if you look at k of x here, we see that it's expressed in standard form. Highest degree term is going to be the leading term, and then we go in descending order thereafter. So we're going to start with x squared, and we see we have nothing to combine with it, so we're just going to start with x squared. So that's done. Then we see an x, negative 3x, that combines to negative 2x. Constants, so plus 1, plus 7, plus 8. And these constants, and this is something I neglected to mention in the previous video, um, these constants can be thought of. So this 8 right here, we can say that it's 8x to the 0 power, right? So I don't know, you probably already put 2 and 2 together with that, but just in case. Okay, so that's us combining f and g, just with addition. Now let's find the difference between h and k. So to find the difference, well, obviously that means to subtract. So we're going to find the difference between h and k by subtracting. So again, literally we have negative 2x to the fourth plus 3x squared plus 9. And we're going to take away from it negative 5x to the fifth plus 6x squared plus 3x plus 4. And now you see the importance of the parentheses. So here on this left term, we aren't going to need the parentheses. Nothing's being distributed into them, right? But here on this right term, uh, we are going to have a minus get distributed into here, right? And that's going to give us a whole bunch of sign changes. So I'm going to go ahead and do that. So the negative uh, times the negative 5x, well, that gives me now a positive 5x. And everything else just changes sign. So that becomes a negative 6x squared. That becomes a negative 3x, and that becomes a negative 4 now. Okay, so now all I'm going to do is combine like terms just like I did on the previous example. So let's start with the highest degree term. Okay, so 5x to the fifth has nothing to combine with, so 5x to the fifth, we've accounted for that. Now we go to the next highest degree term, which is to the fourth power, so we're going to say minus 2x to the fourth. It won't combine with anything else. Then we have the second degree terms, right, here and here. So those two are going to combine into negative 3x squared, right? And then we see a first degree term all by itself, no one to combine with. And then we have the constants, plus 9 minus 4, that gives us plus 5. That would be our final answer here of h minus k, right? So one last thing, we're going to look at how to multiply polynomials. And again, not anything new. We've been doing this. Okay, so f times h, well, that just means f times h. So f times h, and just always remember anytime terms are just next to each other like that, especially in parentheses, that is indicative of multiplication, right? So all I'm basically doing here is really complicated distribution, or you can think of it as foiling, kind of. Um, Idea is the same. I'm going to distribute this first term, this x here, into every one of these terms first, right? So that's going to give me, and actually I'm not going to have room right there. That's going to give me, so let's start with the beginning term. I have too many lines drawn. So let's start here. So x times negative 2x to the fourth, well, that becomes negative 2x to the fifth. X times 3x squared, so that becomes positive 3x to the third, right? And I take for granted, you know, when you multiply two numbers um, with the same exponential base, so if I've got x times x to the third, well, it's understood this is to the first. You multiply, you add the exponents. Okay, so pretty sure, again, we put 2 and 2 together there, but just in case. Then x times, well, x times 9. Well, obviously, that's just 9x. Okay, now I'm going to multiply everything by 1. And of course, that's going to be relatively simple. Okay, anything times 1 is just itself. Okay, so now it's just a matter of combining like terms, right? And we see negative 2x to the fifth combines with nothing, so we're done with that. Is there anything to the fourth? Yep. Is there anything else to the fourth? No, so that combines with nothing. Uh, Nothing to the third power besides 3x to the third, right? And nothing to the second power besides 3x squared. So we literally have nothing to combine, which is pretty brutal. Okay, so this should be our guy uh, in standard form. A polynomial with 6 terms to the fifth degree. That means it has 4 points of inflections and 5 possible x-intercepts. Um, Either way, there it does have 5 roots, and if it was an equation, it would have 5 solutions. Okay, so just kind of reiterating what was seen in the last video. Okay, so that does it for this one. That's how we're going to add, subtract, and multiply polynomials. If you have any questions, shoot me an email. Otherwise, you know where to find me. Goodbye.